In this lesson, we're learning about the last kind of special segment inside triangles. We're learning about midsegments. And midsegments are the segments that connect midpoints of the sides of a triangle. So if you notice this playground here, the crossbar is a midsegment of triangle ABC. And I don't know how well that's showing up on your book, but I don't see it very clear on my screen. Here's triangle A, B, C. This segment DE is the crossbar. It is a midsegment because it is connecting the midpoints of AB and AC. So in this activity, they want you to construct the midsegments of a triangle. And in order to do that, you need to find the midpoints of two sides, which means you need to sort of do the perpendicular bisector construction of two sides. And the reason why I say sort of is if you look at this screen where I have done those constructions, you see that I actually didn't draw the perpendicular bisector. What I did is find the line that would go through those two intersections, and in doing so, that line would pass through the midpoint of the side. So that's how I located the midpoint D and E of segments AB and AC respectively. Then on this screen, it's asking you to use a ruler to compare the length of DE to the length of BC. And in trying to make this video as manageable and watchable and not lengthy as possible, I've already done that for you. So I measured the length of DE, it's approximately 4.8 centimeters. I measured the length of BC, it's approximately 9.6 centimeters. So what does this tell you about DE and BC? DE, the midsegment, is half the length of the side it doesn't intersect. We were also asked to measure angle ADE and measure angle ABC, and so I did that, but I want to make sure that you know where those angles are. I know some of you are still struggling with the naming of an angle and seeing where it is in the diagram. Here's angle ADE. Here's angle ABC. And they're equal. Notice that they are also, they share this side, sort of. So that is a transversal for these two lines. The angles ADE and ABC are on the same side of that transversal. They're both above their lines. So since I have corresponding angles that happen to be congruent, that means that DE is parallel to BC. By the converse of the corresponding angles theorem. So a midsegment is formed by connecting the midpoints of two sides. So the midsegment is parallel to and half the length of the third side. The side that it doesn't intersect. And in this example, example 1 part A, they have us showing that algebraically. So they have the triangle HGI, and they algebraically found the midpoint using the midpoints, J and K, using the midpoint formula. Remember, you saw that in Module 1. It's just the average of the x's and the average of the y's. So they found the midpoint of GH to be -6,2. They found the midpoint of IH to be -2,4. And then they connected dots to make midsegment JK. So that's all step 1, is finding the midsegment. In step 2, to verify that the lines JK and GI are parallel, they found the slopes of JK and GI. We did that in Module 4 because we know that the slopes of parallel lines are equal. So they found the slope of JK, and it's 1/2. And they found the slope of GI, which is also 1/2. And since the slopes are the same, JK, the midsegment, is parallel to GI, the third side. Then they used the distance formula, which we saw in Module 1, to compare the lengths of JK and GI. So they found the length of JK, it's 2 times the square root of 5. They found the length of GI, which is 4 times the square root of 5. And since 2 square root of 5 equals half of 4 times the square root of 5, JK, the midsegment, equals 1/2 GI, the third side. Most of what you'll be doing in your homework, however, is just using those properties to find missing segment lengths or missing angle measures. So, for example, in example 2, part A, we're using the triangle midsegment theorem, given to you here, to find the length of segment UW. Well, here's the length of segment UW. It is a midsegment. And since it's a midsegment, it will be half the length of the side that it doesn't intersect. That's why you see in your textbook that they say the length of UW equals half of 10.2, and they found it to be 5.1. In part B, they're asking us to complete the reasoning in order to find the measure of angle SVU. I know that UW is parallel to ST because of the triangle midsegment theorem. I know that the measure of angle SVU, that's this angle, will equal the measure of angle VUW, because they're alternate interior angles. So this is the alternate interior angle theorem. So substitute 41 for the measure of angle VUW, and that will tell me that the measure of angle SVU is 41 degrees. We're asked in this reflect question, how do you know to which side of a triangle a midsegment is parallel? Well, since a midsegment intersects 2 sides of the triangle, it must be parallel to the third. So how do you know to which side of a triangle a midsegment is parallel? The side that it doesn't intersect. In this your turn example, we're asked to find a few measurements. Let's start with JL. So here's the length of JL. It is parallel to mid-segment PN, and I hope that you would notice that for both properties, it's the third side. The length of the mid-segment is half the third side. The mid-segment is parallel to the third side. So that PN that's parallel to JL, it is half of JL. So JL equals 2 times 39, which is 78. I'm also asked for the length of PM. So here's PM. It is a mid-segment, so it will be half the third side. So the third side for PM is the side that it's parallel to. That's LK. So PM is half of 95, so that's 47.5. Finally, we're asked for the measure of angle MLK. Since it is a corresponding angle to angle JMP, it will equal JMP. So measure of angle MLK equals 105 degrees. In the last example, we're asked to explain why XY is not a mid-segment of the triangle. Since XY does not divide sides of the triangle into equal segments, X and Y, are not midpoints.